All right, guys, today we have another episode of Code Like a Pro. The next 6 videos we are going to be focusing on the SOLID principles. If you've never heard the SOLID acronym or you're not familiar with it, don't worry, we're going to get you caught up to speed. This video is going to focus on a high-level overview of all the principles, sort of their origins, what the point of them are, or is rather, and what we're trying to accomplish by following the SOLID principles, and how it can make you a better developer so that you write cleaner, more maintainable code, and that you go from that junior level to senior level. And the SOLID principles are a huge factor of that, so that you can continue to write better code as well as level up your code game. So let's go ahead and dive into it. I want to take a moment to thank our long-term sponsor, Dev Mountain Coding Bootcamp. You can check them out at devmountain.com. You're saying, Dylan, I'm looking to level up my code game. How can I get better? Well, Dev Mountain is an excellent choice. They offer not only iOS bootcamp courses, but also full stack, JavaScript, Salesforce, quality assurance, UI, UX. Some of them are online, and some of them even include housing, so you can get up and go today. Check them out at devmountain.com. So what are the SOLID principles? Well, as I mentioned, it is an acronym, and the S stands for the single responsibility principle. The O is for the open-close principle. The L is the Liskov Substitution principle. The I, which is one of my more favorite principles of the SOLID principles, is the interface segregation principle. And finally, we have the dependency inversion principle. So there's a lot of principles going on here, 5, right? Somewhat intertwined, some of them. All of them are important, and we're going to dive into a little bit about the history of the SOLID principles. So where, or who rather, did these principles come from? Where did SOLID come from, right? Because these things don't just come from nowhere. And they came from Robert C. Martin, who you might more affectionately know him as Uncle Bob, who is the author of Clean Code, the Clean Coder, and Clean Architecture, which if you haven't read the Clean Code, the Clean Coder, regardless of what skill level you're at, whether you're a super senior or you just got started today, I highly recommend those books. And Clean Architecture I recommend as well, but I think you should wait till you probably have at least a junior level role. And there's links for all that in the description below if you're interested. But with that being said, he introduced it in a paper in 2000, about almost 20 years ago, on the design principles and design patterns. And that is really what the SOLID principles are. They're ways for us to write our code and deliver some things. And we're going to talk about why we should write our code in such ways so that they support certain development practices. Now, he's also the co-author of the Agile Manifesto. And you might be saying, well, why is that relevant? Well, because that's part of the SOLID principles goals. If you've been working in software development for the last 10 years or so, what you've probably seen is that the waterfall software development life cycles are dry and dead, and Agile is a flowing river, if you will. And so that is what we're trying to accomplish with the SOLID principles. Is in general, I would say that they are designed for object-oriented programming, but that you can use them with other functional stuff. But it's most performance, not the right word, but I'd say it aligns best with object-oriented programming. I would also say that it's language agnostic. This isn't something that you just do for Java. This isn't just something that you do for JavaScript or C# or your language of choice, Go, whatever, Rust, whatever it is. And that's one of the great things about it. And it also supports Agile. So as I mentioned, Agile is sort of the way of of software development nowadays. And because of that rapid development life cycle, that if you're doing Scrum, you have 2-week iterations where you're delivering features every 2 weeks, right? We have some places are doing continuous integration and continuous deployment, meaning when it goes out, it's out. Like, it goes straight to master. And so we need to make sure that our architecture is great, and we need to make sure that the testing and the test-driven development processes are followed, and these solid principles help us to do that. So why does it help us do that? Well, it helps us accomplish a couple things. It helps our code to be more understandable or readable. It helps it to be easier to maintain, and it allows it to be flexible. So the strengths of the solid principles is it abstracts some things, so when changes happen, it's much more flexible to get them to work, and it allows us to extend things instead of breaking things and having to rewrite things. And so that it's much easier to add something than to have to rewrite an entire thing. And that's one of the strengths of the solid principles. And it accomplishes these three things through the 5 principles. All right, so let's go ahead and dive in a little bit to each one of these principles and just give a high-level overview of what they're trying to accomplish. So the single responsibility principle. The famous quote, "A class should have one and only one reason to change." So this is about good organization of your code and understanding how good inheritance works, and understanding how to write our code in such a way that things are bite-sized to a degree and are not going to have more than it should, right? We'll give some code examples, but there's a lot of, and we've talked about this in other clean code series, where you don't really want to pass booleans in to tell it to do one thing or another. For instance, that could, depending on the situation, change the logic that's happening. Not if something should happen, but it's like, hey, do it if it's this person, or do it if it's this other customer type. That might be something where now we have multiple responsibilities in a single class. We don't want to do stuff like that, because it makes it much harder down the road to follow the logic, to follow the code. But it's all about keeping things into the bare bones minimum that a certain object should do, and enforcing that with the single responsibility principle. So we, after the S comes the O. Open close principles. You should be able to extend a class behavior without modifying it. So this goes to my earlier statements about we want to extend functionality. We don't want to modify functionality. And principles are in a perfect world, right? Sometimes requirements don't come through, and sometimes this isn't possible, but this is the general idea. These are what we are trying to follow in a perfect world. And so another item about this is you want to be able to, if you're following proper inheritance, you should be able to swap in different versions of different services and items like that. So you can extend maybe an interface that will go in for your service, or items like that. And the open close principle refers to that. It'll make a little bit more sense with code. I did a very poor job explaining that. But essentially, we want to extend items without changing the code base, right? So if we're adding a new feature, in theory, we shouldn't really need to modify the previous code. And if we have written our code in such a way, we're going to add upon it instead of modifying what we already have. The Liskov Substitution principle, and I don't know too much about the gentleman named Liskov, but he had some good insight here. So most of these principles are not necessarily Uncle Bob's ideas, but ideas that he has used and catered and somewhat tweaked and over the last 20 years or so put out there and that's sort of his goal, to get software developers to write them. And Liskov is just one of the many people along the way that have he has learned from, I suppose is what I'm trying to say. So with that being said, derived classes must be substitutable for their base class. So in any good object-oriented programming language, you usually have a base class that you can extend to your child class. an example of this, an excellent example on Stack Overflow, if you were to look this up, is a square class extending from rectangle. So the reason that you wouldn't be able to essentially swap the base with their derived classes is because they function differently, right? At first thought, it may seem that, yeah, you know what? Why wouldn't they? Why wouldn't one inherit from the other, right? Every square is a rectangle, but not every rectangle is a square. And that should be your hint right there, because if you can't swap them out, then there's something going on wrong here, and you might want to rethink your approach, right? Because let's say you change in rectangle, or in a perfect square, you always want the length and height to be the same. So there might be logic in there that would handle that, but that's not necessarily the case for a rectangle, so you wouldn't necessarily swap them or inherit from one. And so those are the types of things you want to think about, because there's probably a better approach than inheriting from a class. And so that's what the Liskov Substitution principle, derived classes must be, you must be able to substitute them for their base level classes. So the interface segregation principle, one of my favorite principles, I like a lot of them, but the clients should not be forced to depend on methods that they do not use. At first glance, this quote, I probably could have chosen a better quote, but the idea here is that you don't want to couple the code so tightly that you can't make a change without making changes in multiple places. And so to help facilitate that, we add a level of abstraction, which we do through interfaces, and this allows us to do a lot of things. Once it allows us to easily overwrite code if we need to, right? So like a common use that I use the interface segregation principle for is testing, right? So sometimes when you're testing on the front end, you might inject an interface, and it's going to, that your service extends, and then you can maybe mock it out or expect different things or override it. There's a whole bunch of different things that you can do with that. But the interface segregation principle is key to that, because if we were passing in the actual service call itself, it'd be very difficult and probably actually hit the API, so we don't want that either. But we'll dive more into that. But the idea here is that twofold. One, that you should have a layer of abstraction, and two, that you shouldn't force people to use things that then makes it so tightly coupled that that you can't override it. And that's the idea here with the interface segregation principle. Now, if you haven't noticed by now, I've said the word abstraction about 15 times. And in the dependency inversion principle, that will continue on. So high-level modules should not depend on low-level modules. Both should depend upon abstractions. This goes back to depending on, not necessarily interfaces, although you will, but depends on, instead of having your actual code depend on other aspects of your code, what you want are to have those abstraction layers that you code in there, and that allows a lot of flexibility, especially when it comes to testing and mocking things out. And so the dependency inversion principle helps support that as well. All right, guys, I hope you enjoyed this high-level overview of the solid principles. If you're feeling a little overwhelmed, you've never worked with the solid principles, and obviously we didn't show any code, but that's what the next 5 videos are about. So next 5 videos, we're going to be starting with S, going all the way down to the D, and we'll be devoting some time with code examples, showing examples of this, how I would use this in my day-to-day operations. So that hopefully makes a little bit more sense. But I hope you enjoyed the video. As always, don't forget to comment, like, subscribe, share. If you're interested in any of my courses or the books I recommend, they're in the description below. I'll see you guys next time. Bye. Hey guys, thanks for watching the video. Don't forget to check out my 100 Algorithm Challenge course. Get you prepped for those technical interviews to make sure you get nice offers. I actually just added some new content to it so you can get prepared for those technical phone screens as well. There's a link in the description to get it for just $9.99.